Create a tool library. After completing this video, you'll be able to create a digital tool library and create a custom tool. In Fusion 360, we want to begin to create our digital tool library. This digital tool library can be stored in the cloud or locally and is going to live independent of our part. So we can get started by navigating to the Manufacturer workspace in any design, and over in the Manage section, select Tool Library. There are two main areas that we can store a tool library: inside of the cloud or in a local storage. The way that we can determine how we want to do this is whether or not you install Fusion 360 on multiple computers. If you do happen to use Fusion on multiple computers, it can be helpful to use the cloud option, as your libraries will be available. There is another way in which you can store your tool libraries in an assets folder if you are sharing them throughout your organization. But for this course, we're going to take a look at using the cloud library. If you don't happen to see cloud as an option, you want to make sure that you go up into your user preferences. In the general area, select Manufacturer and navigate to Enable Cloud Libraries. Once that's checked, you should see a cloud library option inside of your tool library. From here, there are going to be a couple of main ways in which we can create tools. The first of which is to import an external tool library. We can create one from scratch, and we can also copy and create tools into either version of those libraries. We can also create tools completely from scratch as well. To get started, if we right-click on Cloud, we can select Import Library or Create a New Library. If you want to use a new library from scratch, you can do that option. However, we're going to start with a single tool and a single holder in an imported library. You want to navigate to the location of your 3-axis sample library.tools file and select Open. This contains a Cat 40 ER32 style holder, and it also contains a tool that is a 1/4-inch flat end mill. You'll notice that both of these have come from the Haas tooling catalog, and there are product links for both. Inside of here, we can see all the information about this tool, such as the length below holder. This exceeds the 0.75 inches that we need, the flute length, which is over the 1/2 inch that we need, and the type is a flat end mill. So this end mill is going to fit all of our needs for our 1/4-inch tool. However, when we are looking at our process plan, we do want to make sure that the tool number identified here does match what it needs to be inside of our tool holder at the machine. In our case, it is tool number 5, but to change that, we would simply right-click, edit the tool, and go to our Post Processor tab and change the tool number to whatever we need to match our tool library. The next way that we can create a tool is by copying one from a sample library. It's important to note that Fusion 360 has a download vendor libraries option as well. We're not going to be exploring that inside of this lesson, but make sure that you do look at downloading vendor libraries if you do use a lot of off-the-shelf tools from certain manufacturers. When we look at our Fusion 360's sample library, you want to make sure that the library is turned on. You might need to right-click and allow the Turn All Libraries On underneath your Fusion 360 sample library. From here, we're going to be using our tool filters, in this case, milling, and then we're going to be looking for a ball end mill. We're going to find a 1/4-inch ball end mill. Then we're going to right-click and select Copy. From here, we want to navigate back into our cloud 3-axis sample library, and notice that we don't currently see anything here. And that's because the tool filters are active throughout the entire tool library. We cancel those, we're going to right-click and paste the tool. This is going to bring in the 1/4-inch ball end mill. Notice this currently doesn't have any tool number associated with it, and we can also see information about the tool. It's a good idea for us to right-click and edit the tool. We can see the description. There's no vendor or product ID, so if you are using a tool from a specific vendor, it's a good idea to populate that information. In the cutter section, we want to make sure that all of the parameters and information match our physical tool. In this case, the number of flutes, the diameter of the tool and the shaft, the overall length, the length below holder, our shoulder length, and our flute length. All of these are going to be fine, keeping in mind that the length below holder of 0.85 is going to be relatively close to our part, but we should still have plenty of clearance. This is something that we can validate in simulation and make adjustments later. Underneath the holder section, note that it's coming in with a Meritool Cat 40 ER32 holder. You would want to make sure that you validate the holder that you're using because that is going to be an important part of collision checking. In this case, we're going to continue to use this Cat 40 holder and move on to our cutting data. The Fusion 360 sample tools will have cutting data presets. These can be added, adjusted, edited, or removed as you see fit, as long as you've copied this into your own library. Tools in the sample library are going to be read-only. From here, the main thing that we want to look at is aluminum finishing. We want to ensure that the spindle speed matches the machine that we're using. So if you have a spindle speed or feed rate limit, you want to make sure that you do enter those values. In this case, we're going to assume 8100 RPM is the upper RPM of our machine. You can see that the cutting feed rate comes in at 125 inches per minute. Anytime we see an FX listed next to a parameter, this means that it is linked, and if you hover over this for long enough, the bottom of the tooltip will display where that parameter is coming from. In this case, it's an expression called tool feed cutting. Now, in this instance, we're going to leave those values at 125, but make sure that you do validate based on your tools. We'll also note that we have passes and linking parameters. This is going to be a max step down for the tool and a max step over. These are going to be used when we start creating tool paths. We can turn these options off, which will allow us to manually enter those values, but leaving these on does not prevent us from changing them in the individual toolpath. It's a good idea to set these values at a known good value for your tool. In this case, I don't want this tool to be going down 0.5625 inches. I don't want to exceed the radius of the tool in this example, so I'm going to say the max step down is going to be 1/8 of an inch. Last, on the post-processor section, we're going to make sure that we have a tool number that matches where this is going to be in our holder. For us, that's going to be tool number 6. This automatically changes the length and diameter offsets, which is how your Fusion 360 toolpath data is going to get converted when we post-process. Notice that changing the tool number automatically updates the length offset and diameter offset. These values are going to be used in your machine's control to validate the tool diameter and the tool offset parameters. So make sure that these do match unless you have a very specific reason for them not to. We're going to select accept, and now we have tool number 6, our 1/4 inch ball end mill. The last tool that we're going to need is going to be a 1/2 inch ball end mill. Once again, we could go to our Fusion 360 library and find a sample, or we can create one from scratch. We do this by selecting the plus icon. We'll select the milling geometry type that we want, and in this case, we're going to enter a 1/2 inch ball end mill as our description. In the cutter section, we want to make sure that it does match. In this case, we're going to use the unit as inches. The diameter is going to be 1/2 inch, 0.5. The tool diameter will automatically update the shaft diameter. The overall length of our tool is going to be 3 inches. The length below holder, we're going to set at 1.5 inches. And the shoulder length is going to be 1 inch. And the flute length is going to be 0.75. This is going to update the preview of the tool on the right-hand side. However, you will note that we don't have a holder currently defined. If we go to our holder section, notice that we can use holders by selecting one from our various libraries. In this case, our 3-axis machining does contain our Cat 40 ER32 holder from Haas. We're going to select that holder and it'll be applied to our tool. So back in our cutter section, the amount that we have below the holder is going to represent the amount that the tool will stick out. Again, these values can be adjusted, but they should match a physical tool that you are going to use. If you don't use the values of a physical tool and holder that you have, you won't get any value out of simulating and checking for collisions. I'm going to go to the post-process section and make sure that I set this as tool number 7, and then I want to validate cutting data. Note that when we create a new tool, we don't get any default presets. We don't have aluminum roughing or finishing. We need to manually enter these values. Once again, we are using an 8100 RPM spindle, so I'm going to set that as my max RPM. My cutting feed rate right now is relatively low. I'm going to increase this to 80. Notice how that updates our feed per tooth. We should validate this feed per tooth value based on our tool manufacturer's numbers. We also have use step down and use step over values that we can modify. In this case, a step down of 0.03 is probably going to be too little. I'm going to set this at 0.06. And the step over amount, I'm going to set at 0.125. While that is much less than the diameter of our tool, it is important to note that we're going to be using this tool for finishing, and the step over value is going to end up being much smaller. At this point, let's go ahead and accept this and note that we now have tool 5, our 1/4 inch flat, tool 6, our 1/4 inch ball, and tool 7, our 1/2 inch ball and mill. These are going to be all the tools that we're going to use, but once again, if you want to create or use any other tools for your design, go ahead and create them inside of this sample library, and we can access it once we start creating our toolpaths. If you've made any changes to your design, make sure you save that, but the library is automatically saved in the cloud, so there's nothing else that we need to do besides move on to the next step.